Systemd's main purpose is to control Linux services. Let's see how that works in practice and create one new and, well, completely useless Systemd service to illustrate the process. We have Systemd service which is starting Nginx process. It will be started after the network is initialized and the host and network name resolution services are running. For startup of the Systemd service, the Nginx binary will be executed with some specific options set. There is also setting what to do when systemctl reload Nginx is executed. Nginx config will be gracefully reloaded then. And finally, our service will start when the system reaches the multi-user target. Multi-user target normally defines a system state where all network services are started, and the system will accept logins, but the local graphical user interface is not active. Let's create our new Systemd service. It will be started after the Nginx service, and it will be executed with user root. It will actually do a loop and query if the Nginx service is active, and if not, it will start it. After a new service configuration file is placed or a node 1 is edited, a daemon reload command should be executed in order for the changes to take effect. Then we can start our new service and enable it for startup during boot time. Let's open the syslog in second window just to monitor what happens in real time. Next, we can stop the Nginx service. Once the service is stopped, this change is detected by our new useless machine service and the Nginx is started again. Now, let's continue building and expanding our new setup. We can create another Systemd service, which will execute a bash script. The bash script will print some log messages in syslog and play a sound. Then we will create a path Systemd unit. Path units are used to monitor files and directories for changes. Path units can start another Systemd units when activated. We can now try to start our newly created path unit. But the Systemd files are changed, so we should do a daemon reload first. We will tail the syslog again and start modifying our Nginx config. Our path unit is now triggered as it is watching the Nginx config for changes. And then our alert service gets started as it is set to start in the path unit. We can actually make it a little bit more useful by converting the alert Systemd service to a service which will reload Nginx when a configuration change is detected. Let's try that out. Nginx responds at /URI, but on /data we get a 404 response, as there is no configuration for it. We will now add a second location in our Nginx config to handle the /data URI. After the file is saved, the path unit is triggered, Nginx is reloaded, and its new configuration is active. UDEV allows identifying devices based on their properties, like device type, vendor ID, and device ID. Let's use it to identify when a new USB device is plugged in our computer. First, we'll create one more service, which will log to syslog and play a sound when started. Then we'll start monitoring UDEV for devices and plug our USB flash drive. We can see that USB device is added. The subsystem is USB and the device type is USB device. Let's code that in an UDEV rule that will trigger our new alert service. And now let's plug our USB device again and check the syslog.
Hello.
These were some small examples of how to use Systemd. You can check out the full Systemd video for more details on the topic. Thanks for watching.
Let's go. I wake up to a little bit of drool on my pillow, feel like it's gonna be a bad day. Yeah, I'm tired of shit, and the coffee ain't hit yet, damn, ain't that great. I don't wanna go to work, cause my boss is a jerk, and I'm not even that paid.